Okay, welcome to the video on radians and degrees. So in this video, we're going to cover three different things. First off, what a radian actually is. Second, we're going to connect that concept with the thing that you know already, which is degrees. And then we're going to work on converting them back and forth between radians and degrees, and then degrees back to radians. So let's get started. Oh, there you go. So first off, let's figure out what a radian actually is when we say radians. So what a radian is, it's a unit of measurement. So if you think about distance, there's a whole bunch of different ways to measure distance: feet, inches, miles, kilometers, centimeters. Those all measure how far apart two things are from each other, a linear distance. There's several ways to measure time. You can measure with hours, minutes, seconds, temperature, and angles is another thing that we measure. Now, right now, unless your geometry teacher went into it, right now you've probably only worked with degrees. So if you think about the 30, 60, 90 triangle that we did in the previous lesson, it's basically how much an angle opens up is what you're measuring with degrees. So radians falls into that category. So a radian is a way that we measure angles. So then we have two ways, degrees and radians. So just remember what a degree is. It tells us when you're opening up an angle, it tells us how much that angle opens up. So the bigger the angle, or the more that angle opens up, the bigger the degrees are. Then you can go all the way around to full circle. Full circle would be 360 degrees. So that's what degrees are. Now, a radian is another way to measure that angle. So the way that we're going to think about this is we got to think about a circle. This circle just helps us figure out how much that angle opens up. So what you want to do is you want to imagine the radius of the circle. So the radius of the circle is a certain length. So I'm going to take that radius, and basically what you're going to do is you're going to imagine this radius getting wrapped around the circle. So think of it kind of like a piece of wire or something that you're overlaying on top of the circle. So it's that length, but it's a curve instead of a straight line. So your radius again gets laid across the outside of the circle. And as you open up your angle, the length that it has to travel across there, that arc length, that is called a radian, because it's very closely related to a radius. So again, you took this, and then this is a length, and then however much that thing opens up for that length, that's a radian. So this would be considered 1 radian. That's how much that angle is as far as measuring it with a radian. Now, if it's smaller than the radius, say like this one was like half, that's half this length right here, that got laid across here, then that's only half a radian. So however much this angle has to open up to match up the length of that radius is 1 radian. So if it takes, say, like we want a bigger angle, so I overlaid it in purple. So that's basically 2 radians because I took 2 of the radii, laid across the outside to make that. Okay, so that's basically what a radian is. It's a way to measure an angle by using the radius of a circle to see how far open this thing gets. And that's in addition to knowing how to do it in degrees. So just like how you can measure how far away something is in feet, you can also measure how far something away is in yards. So it's just like this one, you can measure how open this is with degrees, and you can measure how open it is with radians. All right, so the next thing is now that we know what a radian is and it measures an angle, we want to make a connection to stuff that we already know. Because we're eventually going to ask you to convert these back and forth. So the connection to degrees is basically we want to think about something that is, if we were talking about length, something that's as far away as the other one. But this one, we need to think about, okay, how can we relate degrees to radians? So if we're thinking about this circle, how many degrees are in a full circle? So when you open up a circle, you keep going and you keep going, and when you get around the entire circle, how many degrees was that? So think about figure skaters, snowboarders, skateboarders. Like when they go around in a full circle, we say that's 360 degrees. Okay. Now let's try to equate that with radians. So just like how I asked you how many degrees is a full circle, now let's figure out how many radians does it take to complete a full circle, because then we have a similar thing that we can kind of connect these two things with. They're measuring the same thing. So let's kind of count this out. So that's 1 radian, that's 2 radians, 3 radians gets you about there. And notice that's not quite half a circle. So this doesn't end up measuring nice and neatly. 4 radians, 5 radians, 6 radians, and then we have a little tiny bit right there that's not quite a full radian. So that's a partial radian. So 6 point something. Okay, we don't know what that is yet, but I know that 360 degrees is a little bit bigger than 6 radians. There's some little piece here. Now we got to figure out that piece though. So 6 point something radians, what's that decimal going to be? Now, it turns out we actually already have a formula to figure out the outside of a circle. You went over it back when you were going over perimeters of different shapes. So the perimeter of a circle, or the outside part of a circle, is given to us by the circumference, which our formula is 2 pi r. 2 times pi, remember pi is about 3.14, and then r is your radius. So that's that length right there. So if you think about 2 pi, 2 times 3.14 is 6.28, or around there, times r. And this r is a radius, but we just said that this radian is a radius. It just got bent. So we can think of this 6-point question radians. That's the same thing as 2 pi r, because r is basically your radians. It's just a radius because it's straightened out right here. So it takes 6.28 radians to go all the way around. So that little green piece is about 0.28 of this radius right here. So 6.28 radians is about the same thing as 360 degrees. It's kind of like saying 12 inches is exactly the same thing as 1 foot, or 24 inches is the same thing as 2 feet. So 6.28 radians is the same thing as 360 degrees. Now, we normally don't want to put decimals and round off, because once we start rounding off a number, we're a little tiny bit wrong, because you're chopping off an entire piece of that number. So to keep it accurate, we're just going to keep this pi symbol on here, because this pi means 3.14159, blah, 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 blah. So we're going to keep that on there, that we don't have to keep estimating. And we know 360 degrees is the same thing as 2 pi r. Now that r, again, means radians. We can simplify this out a little bit more, because 360 equals 2 pi. We can always do stuff like this when we have an equation, but if we divide by both sides by 2, I can just say, okay, 180 degrees, which is half a circle, is equal to half of 2 pi, which is just pi. So half a circle is the same thing as pi radians. This makes it a little bit easier to work with the numbers. And that's basically the connection between the two. So the connection to degrees, 180 degrees is the exact same thing as about 3.14 radians, about pi radians, or equal to pi radians. Okay. Now we are going to use this information to convert back and forth between the two. And this is basically what your homework is on. All right. So your homework's going to ask you questions like convert 30 degrees into radians. So if you're asked to convert things like this, you need to know what the common measurement is. So this common thing is 180 degrees is equal to pi radians. So 30 degrees. Now, in order to convert back and forth, if you remember a previous chapter, I don't want to change the value of 30 degrees. The only way that I can make something look different without actually changing its value by multiplying is by a fancy 1, because 30 times 1 is still 30. Now, if I think about this, if I know 180 degrees is equal to pi radians, if I multiply 30 degrees by pi radians over 180, so I just took this part and put it over this part, this is 1, because pi radians is the exact same thing as 180 degrees. So you have something over the exact same thing. So if you had a 5 over a 5, it would be 1. If you had a 7 over a 7, it would be 1. So pi radians is the same thing as 180. So this is actually just a 1. You're multiplying 30 times a fancy 1. Now, the reason why we do this is because right now I have 2 units. I have a degree and I have a radian. I just want radians. It wants me to convert it into radians. Now, if I set up my fraction like this, your degrees end up canceling off because you have a degree on the top and you have a degree on the bottom. Just like anything else, whatever matches on top and bottom, you can go ahead and cross off. Okay, so those units are gone. So now I just have radian units. I no longer have degrees because my 30 degrees was up top. My 180 degrees was on the bottom. So now if I just multiply 30 times pi radians, you get 30 pi radians. And you're going to look at just 30 and 180 and simplify this just like you would a regular fraction. Excuse me. And you get 1 over 6. So you get just 1 times pi is just pi, so pi radians over 6. Now, normally we like to write our units. So this is a radian off to the side. So just pi over 6, and then just write your radians off to the side. So if this is like the only, I guess, exception to that would be degrees. The degree would just be like up here, which is, I guess, still off to the side. But that would be your answer. So 30 degrees is the same thing as pi over 6 radians. Now, this is an actual number. That's 3.14 divided by 6 is about 0.52. So it takes about 0.52 of a radius to open up. That's the same thing as 30 degrees. All right. Let's try another example. Let's say 1 radian. Let's say we want to know how much a radian is in degrees, and then round your answer off to the decimal places. So again, start your question off with your current unit. Your current unit is a radian. So we're going to use this equation to help us out. Now, our radians are what we currently have. I want to cancel that off and turn it into degrees. So this radians piece needs to be on the bottom. That's going to be on top. So again, whatever unit you're starting with, cancel it by putting it on the bottom, and then the other one's on top. So we're going to multiply by 180 over pi radians, right? And then this radians on top and bottom, those are gone. Remember, pi is just a number. It's not actually a part of the unit. Now just multiply across. 1 times 180 is 180 divided by pi. And 180 divided by pi says round the answer off to 1 decimal place. So 180 divided by 3.14-ish is about 57.3 degrees. All right. So 1 radian is equivalent to about 57.3 degrees. And let's try one more of those. Let's say we had convert 3 pi over 8 radians. Remember, this is just another number. We just didn't want to round off because 3.14159 is a very long number. Convert 3 pi over 8 radians into degrees. Round your answer to 1 decimal place. Now, again, because the units are off to the side for this method of doing things, we're going to go ahead and just put it up top. So 3 pi radians over 8. Your radians are on the top. So that means that I want to write my radian part on the bottom. This one's on top. That way they cancel. You're going to use that. And then now the radians will cancel off. And I also notice that I have a pi on top and a pi on the bottom. So I can go ahead and cross those off as well. All right. And then now just multiply across the top. So 3 times 180 degrees. Make sure you have your units on there because they want it in degrees. So we're going to put our degree on there. The radians are gone, divided by 8. So now just plug that into a calculator. 3 times 180 divided by 8. And you should end up exactly at 67.5 degrees. And that is it. So make sure to email me if you have any questions or stop by my office hours. We have one more video coming out this week. So hope everybody's taking care and being safe. Okay, bye-bye.